So welcome again. This video will probably be the last or second to the last video. I think the last video will probably be actually trying out something, maybe writing a program and seeing how it works with the chip. If not, this will be the last tutorial on the chip, but I'll do this video as the last tutorial for now. But probably in a month's time to come, I'll prepare maybe an application that will work on this circuit. So for now, I think this will be the last tutorial till I'm able to arrange the materials for the tutorial. So I'll just briefly go through everything we've done before, through more light and explanation. So after assembling the whole sub-circuit, this is what we get at the end, the final outcome. So normally in a real circuit you won't have this, you won't have this port in here and then have port out again. They are not input and output, they're actually called in-out pins. It's just like when you have your Arduino pins that can function as input and output. So they're not, the real circuit won't look exactly this way because these ports won't be separate, they'll just be single port, but they can function as input or output depending on how they are programmed. So they won't be separate as it is here. Then again, all the bus pins, something like this bus address, bus reset, bus read write, bus CS, bus data, and bus clock, bus data in also. So what they refer to when they say bus is in a situation whereby you want to add another sub-circuit, maybe you want to add a keyboard, or you want to add another extra RAM, or you want to add a joystick, or you want to add any other peripheral, just like we've already had the ones in the original circuit. So if you have any other new peripheral circuit to add, you won't have to start breaking into the code or trying to manipulate anything again. You just pick these cables. This bus address will now be the normal CPU address that went into all the other peripherals. This will be your normal reset. This will be the read write that we saw in every other peripheral, the same with the chip select. Then this your bus data out, which will serve as the input to the new peripheral you are adding, because this bus data out is the same with the CPU data. When I go into the circuit, you will see it also the same with the bus data in. So the everything here, bus means extra peripheral you'll be bringing into the circuitry. So then the reset and the clock, they are basic units of every sequential circuit. You always have your reset and your clock. The I and O, they are used for debugging. You know, we had this DCD debugging stuff that we talked about during the lectures. Then we have this LED. The LED will just that it won't be doing anything much, it will just be blinking. You just be blinking intermittently to show that the circuit is working. It doesn't do any other thing. Then the CTSN, RS bit, RTSN, and TX bit, they are all for UART. And you know, Arduino have it also. Like when you want to connect to your Arduino to your laptop, you use your UART to USB. Then they have the UART to USB that converts the UART data to USB for the laptop. So the same thing is here. The RS bit, TX bit, RTS, CTS, so they are all used for connecting this 6805 to your laptop or any other RS-232 enabled device. So then we have our timer. Depending on what you program it to be, you can use it as a clock for other circuits, or if you want to add it to other peripheral circuits out there. So this is basically what we designed. Like I told you, if I'm making a circuit, a new tutorial, it will actually be a demonstration of how we can run a program with this. Well, let's go inside and see the different units that makes it up. So let me go back. So this is it inside the circuit we just saw now. So the circuit, this is the internals of our circuit. The inside, the constituents. We talked about the mini UART, we talked about the IO port, we talked about the RAM, we talked about the timer, we discussed the CPU, then the control unit, and then the boot ROM. So whenever I'll be doing the demonstration of the application, that's when I'll be talking about the boot ROM. I didn't really make a separate tutorial for it because it's just a ROM. There's nothing in it. Let me show what it looks like. This is it. There is nothing in it. It's just a ROM. If you open it, the content, there is nothing in it. It's just signals, different values in it. So I didn't want to make a special tutorial for it because there is nothing much to discuss about it. So, but it definitely has a role to play. If we'll be discussing about an application, because like I told you, whenever the circuit starts, is this ROM that first sends data. Is this ROM that first the CPU reads from. The CPU reads from the boot ROM first whenever the circuit starts. So if I'll be making a tutorial to demonstrate how it works, then I'll include explanation. I'll definitely include explanation of how the boot ROM works. So at this point, we already know the control unit stands in the middle. The CPU data goes here, and from here it comes out and goes to every other part of this our circuit. So what it does is just to choose. The control unit generates all the CS to know which one are we turning on. So just like when I was demonstrating the bus signals, every peripheral here have the fundamental signals they are going to have. One is all the peripherals here, we have a clock and a reset, which is basic for every sequential unit. Let me use the timer as an example. The clock and reset is compulsory for all the peripherals, and that is why for the bus, which we talked earlier, that is an SSL secretary, must have a clock and a reset. Then they must have a CS and a read-write signal. The same for every peripheral. See, CS and a reset, CS and the read-write. Sorry, they all come from the CPU. So this read-write is coming from the CPU, and it's going to all of them, telling them whether the CPU is reading or writing. So therefore, the bus too will have the CS and the read-write. So the idea of having that bus is a very good design concept. It's a very nice concept in design, so that in such a way that you made allowance for expansion, not just having to disintegrate the circuit afresh if you're adding something new. So the control unit, I actually mapped it out from from the actual code by John Kent. There wasn't any special code for it. I just picked some codes and formed it out, and gave it the name control unit. So it's a very nice. You can see here all the peripherals are sending their inputs here. So the control unit will choose between all of them and determine which one to send to the CPU. The same thing with the CS. It chooses which of the CS to turn on to allow them to receive the CPU data. And you can see it also have the bus data in, just like it have the data in of the rest, so that the new bus you are bringing in will input its own data there also. So this is basically, I did well. I explained each of them perfectly well except the boot ROM. Some people might still feel a little bit confused with the CPU. Let me open the CPU again. This is the CPU. So we've taught everything possible conversation we can have on this CPU. It's just to test it. So you can see there are so many ROM. We have the normal boot ROM. We have this one, BSET ROM. We have the BClear ROM, and then we have this ROM. So we have like 4 different sets of ROM. So that's the role, a very important role which a ROM plays. They store permanent program data are stored there, so you always make use of them every single time. So you can see in this particular design, the ROM was used to enable the state machine. It enabled the instruction cycle for the CPU. So these are more what the role the ROM can play. We've discussed about the RAM. So depending on the settings too, the stack will be able to access this RAM also. The stack pointer. So I've done justice to this tutorial. Please subscribe to my channel. This is the main circuit. This is the ROM. Sorry, this is the RAM. This is the BSET ROM. This is the BClear ROM. This is the boot ROM. These are the flags which we've talked about them. This is the ALU itself. This is the registers. This is the ALU the mapping. This is the CPU top. This is the TX unit of the UART. This is the RS unit of the UART. So the UART and the UART itself have RS and TS units. This is the top of the TS unit, RS unit. Now this is the mini UART itself, where we included the RS unit and the TS unit were included. This is what it looks like. Then at the end we have our UART top. I actually tested this when I was discussing the UART. How we demonstrated how to send and receive data using this mini UART. Then our timer subcircuit. This is the timer, the top of it. This is our IO ports. The top of it is the ports, what they look like within. Then this is our control unit, and finally this is our 6805 SoC CPU architecture algorithm and everything that has to do with it. So please kindly subscribe to my channel, and thanks for watching this. I hope you've learned a lot. I have my email on my website. You can send me an email if you have any further question. concerning this topic. This will be all for now until I have prepared a separate tutorial where I will write and run an application on this. I'm also still trying to understand it like you. So when I'm through, I'll write an application and run it on this circuit. So we'll see how it works. Thank you. Have a nice day.